Hello, today we're going to be talking about congruent figures. We've talked about congruent angles and congruent segments, and essentially it's all come down to things are congruent if they have the same measure. Now, that changes slightly when we're talking about 2 or 3-dimensional figures. For 2 figures to be congruent in the 3-dimensional or the 2-dimensional world, not only do they have to have the same measure, which we're actually going to call size, they, in addition, also have to have the same shape. So for things to be congruent, they have to be exactly the same. They have to have the same size and they have to have the same shape. Now, size of a 2-dimensional figure, like a rectangle or a triangle, is going to be determined by the side lengths. That's going to tell me how big something is. Whereas its shape is going to be determined not only by the number of sides, but by the angle values. Because you think about if you've got some triangles, a right triangle and an isosceles triangle, or a right triangle and an equilateral triangle are going to look different. Even though they're both triangles, their shape is going to be slightly different. So that's going to depend on their angle values. Now, when 2 figures are congruent, the key thing is trying to find the matching parts or the corresponding parts and making sure that those are congruent. So we want to find that all the parts of one figure are congruent to the corresponding parts of the other figure. Now, corresponding, not the best word, just because you spent all this entire last unit talking about corresponding angles and alternate interior angles. But when we're talking about these congruent figures, corresponding parts just mean the matching parts. The parts that match up in size, that match up in shape. And that's truly what it comes down to for these congruent figures, is finding those corresponding parts. Now, one way that we can find our corresponding parts is just by looking at our figures and looking at, okay, what appears to be the same size. So if I'm looking at this picture here, you can see that angle L looks to be the same size as angle W. And that's a good way to start. But remember, we've talked about this before. We don't trust our pictures in geometry. We don't trust what things look like. Just because something looks like it's a 90-degree angle doesn't mean it necessarily is. Or just because something looks like it's the same size as another thing doesn't mean it necessarily is. We need something stronger than that. So this whole how could you use scissors check, we could use that as a way of checking angle sizes. So opening up a pair of scissors to get the correct angle and then sliding that over and seeing if that's going to match. But there are other ways with these congruent figures to determine whether or not something is, whether 2 figures truly are congruent to each other or not. So if we look at the top of the next page, we have the same picture. We still have those same 2 figures there. But this time, we're given not only the pictures, but we're given actually the names of our figures as well, which can be helpful for us in the fact that when we have these congruent figures, we name them in very specific ways. Okay, I'm just trying to see if I can get the whole picture here. I don't think I can do that, so we'll just zoom back in for a second. All right, so I'm given these 2 congruent figures, and I'm being told that they're congruent in what we call our congruent statement right here. And we'll get into a little bit more details of what that is in just a minute. But this right here is giving me my 2 figures that are congruent, and the best part about a congruent statement is the name is meant to help us. Because when you name your 2 figures and you state them as being congruent to each other, we name them. So not only do we have the names the correct thing, but they're named in the order of their matching pieces. So L and W are both the first letters in the individual names. That means angle L and angle W need to be matching pieces. They need to be a pair of corresponding parts. And I can do the same thing with the next ones. Angle M and angle Z are both listed second. So angle M and angle Z need to be a pair of corresponding parts as well. And I can go down the line. So if I want to name off my corresponding parts, I can start with my angle values because it just tells me in the order of my name what has to match. So I know angle L needs to be congruent to angle W. Angle M needs to be congruent to angle Z. Even if it doesn't necessarily look like that in the picture, we're going to trust the name over what our eyes tell us on the picture. Angle N has to be congruent to angle Y because they're both third in their names. And angle O has to be congruent to angle X because they're both last in the names. So those are my 4 pairs of corresponding angles. But those aren't the only parts that match up. I also have these side pairs. So I can list those off as well. And I can use my picture to help, but I can also use my name. Because when I go to name my pairs of sides, I want to still keep the order. I want to name the sides so that the first letter in the side on the left matches the first letter in the side on the right. So if I start with side LM, LM is going to have to be congruent to WZ. And I want to name it in that order because L and W match, M and Z match. Now on a quiz or a test, if you were to flip that order, I'd probably still give you full credit, but we want this. This is what we really want to do. LM is congruent to WZ. We want to keep the order. And I can go down the line and I can do MN is congruent to ZY. And I want to remember to name these with the segment bars above them because there are segments. NO is congruent to YX. And lastly, OL is congruent to XW. So when I have these 2 congruent quadrilaterals, I'm going to have 4 pairs of congruent angles. And I'm also going to have 4 pairs of congruent sides. And I can use the picture to help, but really it's going to come down to my names. L and W are both first in the name, so L and W have to be a matching pair. M and Z are both second in the name, so M and Z have to be a matching pair. That leads us into what our congruent statements are. Now, the congruent statements are exactly what's highlighted up above. It's when you state what figures are actually congruent. You're listing what's congruent to what else. What triangle is congruent to which other triangle. Which quadrilateral is congruent to what other quadrilateral. So when we write our congruent statements, you can write them for the entire figure, like we have highlighted above. LMNO is congruent to WZYX. Or you can list them for the individual pieces. So the blue segments are all congruent statements. Segment LM is congruent to segment WZ. And so are the purple angle congruent pairs. Those are congruent statements as well. When we do them for the whole figure, we want to list them so that the matching vertices or the corresponding vertices or the congruent vertices are in the same order. And that is key. Anytime you get something from me, it will always be listed in the correct order. And then when you write a congruent statement, we want to remember to use our congruent symbol, the equal sign with the little squiggle above it. All right, so we're going to do 2 examples. First one right here, you got 2 triangles. And this right here, I have my congruent statement. Triangle TJD is congruent to triangle RCF. That's my congruent statement. And we're just going to do what we did above. We're going to list all the corresponding parts. Now that it's a triangle, I'm only going to have 3 pairs of corresponding angles, 3 pairs of congruent angles, and I'm going to have 3 pairs of congruent sides. And again, I can go off my picture, but my picture can be misleading. My names will not be. So we're going to use the names rather than the picture. The picture could be helpful, but it can also be misleading. So we go off of the names. So if I start with my angles, angle T has to be congruent to angle R because they're both first in the name. Angle J has to be congruent to angle C because they're both second in the name. And then angle D has to be congruent to angle F because they're both last in their names. And that does actually match up with what the picture looks like. Okay, but we trust names over pictures. We can also do our 3 congruent sides, and we could have the picture help us, but we can also go off of our letters here in order, and we could start with TJ. TJ has to be congruent to segment RC. Segment JD has to be congruent to segment CF. And remember, I'm still trying to keep the same order. C and F still match. Or excuse me, J and C still match. F and D still match. And then the last one, DT, is still going to be congruent to FR in that order because D and F match, T and R match. We have one last problem to do. And that's this one here. This one we're actually going to use what we know about solving a system to answer this problem here. But before I get too far, what I want to do is I actually want to figure out what this angle down here for W is, because that's going to come in handy. Now, this right here, I have this whole triangle, WYX, or XWY, and we know that for all 3 angles in any triangle, all 3 angles have to add up to be 180. So if I want to figure out this missing angle at W, I can take 180 and subtract away whatever 90 plus 56 is, and you should get back 34 degrees. And that's going to be actually very helpful in just a minute. But I get 34 degrees, so I want to do that before I get too much further into the problem. But when I'm looking at this setup, I'm given this congruent statement right here. I am told that triangle XWY is congruent to triangle PQY, and I'm trying to solve for my X variable and my Y variable. So if I look at my names, I know that angle X and angle P have to be equal to each other. So my angle X of 56 has to be equal to 4X plus 2Y. Now I can't solve that yet because I have one equation with 2 variables. But we can try and set up a second equation so that we can end up solving using either elimination or substitution. And so if I look at my angles W and angle Q, those also match up. So angle W and angle Q also have to be congruent. And that's why we wanted to figure out what W was. Because if W is 34 and angle Q is 5X plus Y, those 2 angles have to be equal. And now I have 2 equations with 2 variables, and we can solve them. So we can either use our substitution or elimination. I think substitution will be a little bit easier. If we take this green equation and we subtract away 5X from both sides, we get 34 minus 5X equals Y. And we can take this 34 minus 5X, use our substitution property, and substitute into the purple equation. And if I do that, I end up with my 56 equals 4X plus 2 times 34 minus 5X. And we can solve. It's just algebra at this point, which we're all experts at, or at least we are remembering how to be experts at that. And we get 56 equals 4X plus 68 minus 10X, or 56 equals 68 minus 6X. And so if we keep solving, I get negative 12 equals negative 6X, or positive 2 is equal to X. And then I can take 2, substitute into X over in that green equation, and get my Y value is 34 minus 5 times 2, or Y value is 24. So using the fact that these 2 triangles have to be congruent, that means that the matching angles have to be congruent as well, and we can set up a system of equations that we can solve.